In our last episode, we began our series on the 12 Orders of Soil Taxonomy. We went over our very first soil order, Entisols, and talked about soil horizons. Today we're going to talk about the next 3 orders of soil taxonomy: Andisols, Aridisols, and Entisols. So stay tuned for Soils with Sorel. Andisols are very fertile soils made from volcanic ash and byproducts. They can hold a lot of water because of their aerated nature, and they have a unique ability to fix phosphorus. No, phosphorus isn't broken. To put it simply, and we'll go over it in more detail in a future episode, fixing phosphorus simply means that there's different chemical reactions in the soil that help to make the phosphorus more available to the plants. A key feature of Andisols is the presence of volcanic glass like obsidian. These soils are the least extensive of all the soil orders, only being found in about 1% of the world's soils. They are found in concentrated volcanically active areas such as California, Oregon, Washington, Alaska, Hawaii, and Idaho. Andisols can be broken down into 7 suborders: aquants, cryonts, torrents, eudonts, eustons, vitrons, and xeronts. Since this soil order is found in a very specific area of the US and the world, a lot of the suborders share the same characteristics, but there are a couple of key differences. Aquants contain a lot more water, so are therefore more saturated. Cryonts are found in colder forested areas. Torrents contain less water, so are therefore less saturated. Eudonts are found in more humid forests. Eustons have limited available water for plant growth. Vitrons have varying degrees of moisture. And xeronts are found in areas that have a more Mediterranean type climate. Aridisols are not very fertile soils and contain little to no moisture to support plant life. They don't have an O horizon and usually have an accumulation of salts because there is not enough rain to wash the salts down through the profile. Aridisols are not good for farming unless you do extensive tilling, nutrient additions, and watering. They are found in the desert regions of the US, including California, Arizona, Nevada, Utah, New Mexico, Texas, Colorado, Wyoming, Idaho, and parts of Washington and Oregon. Aridisols are divided into 7 suborders: argids, chalcids, cambids, cryids, durids, gypsids, and salids. Just like Andisols, Aridisols are found in a very specific area of the US, usually the deserted regions, so their suborders share a lot of the same characteristics such as low moisture content and very low fertility. But I know what you're thinking. Sorel, there's cactus that grow everywhere in the desert, so of course there's got to be something that supports plant life within that soil, right? To that I will say, you're right. However, that goes into detail on plant photosynthesis, which I highly encourage you to look up because I'm probably not going to go into detail on that within my show. Back to the suborders. The differences are very technical and there are a few, but let's go over them in detail. Argids have a higher accumulation of clay and can be transformed, if irrigated properly, to be used to grow food. Chalcids are similar to argids, except they have less clay and more calcium carbonate. Cambids can also be used to grow food if irrigated properly. However, there is little to no B horizon and they are mostly found in Washington. Cryids are found in the high cold desert areas of Idaho. Durids contain silicon dioxide. Gypsids contain more gypsum than any of the other suborders. And salids contain a lot more salts and cannot be used for agricultural use. Entisols are considered a new soil with almost no horizon development. They are shallow and found along rocky, slopey areas near the rocky parent material. Remember we talked about how a soil's parent material is rocks? Because they are new, meaning they have not had a lot of time exposed to the 5 soil-forming factors to form horizons, they are low in fertility and organic matter. But believe it or not, Entisols are the most common soils. Here are the 5 suborders: Aquens, Arents, Fluvents, Orthents, and Saments. Aquens are found near riverbanks, coastal areas, and gulfs. Arents have had human interactions such as plowing, so they could be used in agriculture. Fluvents are found along floodplains. Orthents are mostly found west of the Mississippi. Saments are found across the country, but are very sandy, so they could be prone to soil erosion. So that's it for now. Thank you for watching my channel. On our next episode, we will be talking about the next 3 orders of soil taxonomy: Gelisols, Histisols, and Entisols. But until then, you know what to do. Save the soil.